Where did it go?
There it goes.
Okay. Any announcements?
I would like to add one thing to the agenda.
Sure.
I
Really one or two, or is it?
I think it's really just one thing. Last week we looked at digital RF data from the eclipse. This week, Christina sent me a couple plots this morning, showing the Grape FL digiplots produced by, I think, Bill Blackwell in the New England Grape Group, and I would like to show that so you can see what that data looked like.
Lovely.
We've got a live demo this morning.
Whoa! Now those are the things that can be scary, right, John?
Yes,
Yeah.
very much so.
That's the scariest thing.
And I have one announcement for the group. So you may have seen my post about the switching supply. It continues to work very, very well. These little supplies are only about $20, and you can get a USB adapter for them, and they really clean up the spectrum out of the Raspberry Pi switcher that you get with a kit or whatever. And I noticed that even though you can't really hear it on 10 megahertz because it's a hissy kind of noise. I live in a very, very quiet location, and I could tell by moving the antennas around that the noise floor would kind of come up a little bit, but you didn't hear the buzz like on 160 and 80 meters, and N2IC had the same trouble. If you're having trouble with signal noise ratio, you might want to look into that. Most installations, we're only interested in the frequency, so it's not a big deal. You can just go ahead and use whatever you got. But if you're in a really quiet location, it does make a bit of a difference.
Another comment on that?
Yeah, I was going to ask Stan. He said he'd tried a whole bunch with loops and hadn't noticed a problem. So it's a question of signal noise ratio.
I have a lot of high energy local interference, including a sounder just a mile away, well, less than a mile away. So I have a lot of issues, but putting the Grape in a box is the best thing you can do to clear noise, in my opinion. And the second thing is decouple the speaker lead, the lead that goes to the audio amplifier.
Yep.
RF choke, as big a capacitor as you feel you can put there, and I use twisted wire for all the interconnections, and also I use an isolation transformer between the output and the sound card, a mod toggle, and I terminate the transformer with a 600 ohm resistor and a capacitor to make sure there's a lot of high frequency stuff that's attenuated on the input to the sound card.
And what you guys are all dancing around is what's called the common mode current from the switch mode power supply, which is capacitively coupled through the transformer from the primary to the secondary.
Yeah, well,
that's the biggest issue, because the transformers are cheap and there's no isolation, and that is a main component of doing high-end meter design, is getting rid of that common mode current, because it gets into everything.
I gave up on the switch mode power supplies powering the Grapes in the beginning, and I run on nice old 1970 Lambda 5-volt supplies.
I would be happy to collect this stuff and write an app note on dealing with noise in your Grape. Do you have noisy grapes? I'll collect all this stuff and kind of build an app note, a living app note that has some guidelines. So send me your stuff and your notes and what you've done, and if there's a schematic involved, send me that, and I'll compile them and we can post them on the Grape page somewhere.
The biggest
Big land
bang for the
report.
buck that I have seen is doing proper grounding. And I know I keep beating a dead horse here, but I have no noise problems with the switch mode power supplies, but I've got the grounding set up correctly. And most people don't have a central grounder in their ham shack, which immediately tells me that I'm not even going to bother trying to fix that because you don't have the right grounding.
They need that grounding and bonding book.
Exactly. And they just don't get it. And you can
Well, yeah.
talk
and
to
the
your
thing-
blue in the face and it makes no difference. I've given up on it.
I
Okay.
think what you have discovered is that bonding really pays off a lot.
Oh, yeah.
If you can make everything at the same potential, that stops the voltage that would otherwise drive common mode.
But it's not so much the same potential as you give the current a place to go, because it's going to find a way to get back to ground. And whether it's through your circuit or it's through a ground path that you provide is the big difference.
If the circuit is ground referenced, and it's not always
And most
ground.
everything is just by virtue of the way our power supply system in the United States is set up. The neutral, which is the center tap of the secondary, the transformer, is tied to earth ground. So you have an inherent ground loop and you
Right.
can't get away from it for safety reasons.
I'm out. I think this has turned into a little bit of a discussion and less of an announcement. So
Okay.
if you
Thank
have
you.
paper or
Back to net.
celebratory things, but
Okay.
we do want to move on to the Grape too. Sorry to cut
There
you
you
guys.
go for it.
I do have one thing I do want to show. I have
Sure.
reworked the code that draws the plot of the Grape output. And I want to show that before we put it into production. I want to get everybody to have a look at it, what the new output is, because I changed the way it looks to look a little bit more like what the Grape plots when you're watching its output when it's running, and did some other improvements to it. So I want to show something on that when you come to that.
Okay. All right.
Maybe this would be the time for me to offer my little observation, which is I was experiencing a set of spurs, and I was able to solve it by turning down the drive from the Bodnar. I was wondering if anybody else had looked at that injection level as an issue. I
Actually, what
certainly
you're
had some
doing is
ground loop issues, but other than that, these static spurs seemed very much correlated to the drive.
Yeah, the drive current increasing that it increases the drive current, but what it really does is increases the rise or decreases the rise and fall times. It makes the edges faster, which means anything that's coupling to it, it's going to be worse because of higher frequency content. So that's what's going on. The way the Bodnar is loaded on the Grape 1 does not matter whether you have an 8, 16, or 32 mils, because I don't push that kind of current. But when you increase the drive current, your edge rates go from, like 5 nanoseconds down to 2, and that increased frequency capacitively couples much easier because it has higher frequency content. So that's what's going on.
Okay. It's early in the morning here, so I'll confess that I don't completely follow you, but
Okay.
that's all right. In any event, turning down the drive from the default level did seem to.
Yeah, I think it defaults to the full 32.
Yeah.
Taking it to 16 or 8 would slow down the edge rates, which would decrease the capacitive noise coupling.
Yeah, I found that was a big help. Alas, I found out too late for the annular eclipse, but that may be something that needs to go in documentation someplace.
Well, we're having a completely different setup for Grape 2, but yeah, for Grape 1, that might be a helpful hint. Again, it depends on how you hook it up and how the grounding is set up, because like I say, I didn't run into that problem on mine, but the grounding is a lot different on. No, we'll get into that later. I don't want to go off on a tangent again.
Yeah. Okay, well, that's all I've got. So thank you, Rachel.
All right, John, any update on the magnetometer boards?
Okay, let me share my screen. I can't.
Go ahead.
There we go. Okay. This is the panelization of the Grape 2 RF deck, which is, even as we speak, being made. I had to increase it to a 4-panel to get the pricing down, and for the manufacturability for them to put it through their IR reflow, they needed the rails on the sides to be able to put it through their process. Now you'll notice these little dots here. Those are called fiducials. And what those are targets for the machine vision to allow it to get its resolution down to 1 mil for placing parts like this, which are on 20,000 centers. Because if you're off 2 mils, you're off 10%. That's enough to cause solder bridges. So you have to be within 1 mil when you're placing these parts. And these fiducials give the machine reading of the position, exact position of the board, because you tell it where these dots are, and it goes in and finds them and aligns itself and basically calibrates itself. So these are going out, are being made now. I've got all the parts for them. And the second thing here is I got the quote back, and it dropped down significantly. So for the 2-week turn, we're down to under 5,000 for 55 boards and roughly under 4,000 for 35 boards. So that's where we stand. And if you made the extra 20 board difference again, you would not get the incremental difference price. You'd be back up in here, because as you can see, the majority of the cost is in the assembly, which means they have to set up the line, they have to set up all their workstation, you know, it's all that kind of manual labor stuff that is where the money is being spent. Mm-hmm. So we'll have to have a serious discussion about board quantity, for the simple reason, if I got the 55, it makes my job easier, because I only have to get really 30 of them working, and with a 60% expected yield, it'll make it a quicker turn. So basically you'd be buying time, but Nathaniel and I will have to duke that out later.
I think, John, I think the important thing is that you get me a spreadsheet of what you need. I don't think, you know, I don't think it's worth trying to figure out. Yeah, if you need that extra time, I can see spending the extra money here.
Okay. So, like I said, we have discussions, and I'm just bringing this up because I just got this information yesterday.
Okay.
Because this is a new quote with the quad panel, and it dropped it down by about $1,000.
Okay.
So, and now I am going to hand it over to Bill. Oop, did I shut off you? Oop, let me stop that. There we go. Take it away, Bill.
Okay. Can I share the screen?
Go ahead.
Okay. This is the screen that shows the data coming up from the Pico to the Pi. Basically, what you're looking at here is the timestamp in this field, and then the checksum for the entire data block, which is 120,030 bytes being transferred per second from the Pico up to the Pi, and taking a total of around 363 milliseconds out of that second. So we've got, we're using about a third of the bandwidth. So we got a little headroom to, if we were able to cram more samples per second through, we could. But what I wanted to show you is the timestamp. So the timestamp starts with a T here. That's how we recognize it in the data stream. And then here's the year, month, day, hour, minute, second. And then we've appended a 4-byte field here, which I would just call timestamp quality field, or precision or accuracy, whatever you want to name it. It's 4 separate columns. The L indicates whether the timestamp is GPS locked, and that'll be a U if it's unlocked. The 3 indicates whether it's a 3D fix, 2D fix, or no fix. And if the timestamp is not locked, that'll be a 1, which indicates no fix or dead reckoning. And then the next field is the satellite number, number of satellites in the solution. And this is a hex field, so it'll go up to F in value, which allows us only to count 15 satellites, but that's enough. Normally, much fewer than that will get you a 3D fix. The 4th field is what I'm going to try to make the geometric dilution of precision, GDOP, if I can read it out of the NMEA sentences. So I'm working on that now, so it's not there. So this whole set of characters here will just give the researchers some idea of the quality of the timestamp, whether they want to drop the data, whether they want to include it, how to weight the accuracy of the timestamp. So that's all I wanted to show. Any feedback would be appreciated. Oh, and then I could show you what happens when I disconnect the GPS antenna. Let me do that.
Now we're living on the edge.
Yeah. This is okay. So watch the L field. So that's gone to U now, which means unlocked. But we're still getting samples because the oscillator is free running. It's not locked to GPS, but we're still getting samples. There it jumped back to locked for a minute, and then back to unlocked, and you can see the fix went to no fix, which is a 1 code, and the 0 is 0 satellites. Now I'll plug the GPS antenna back in. And it's gone to 2D and then 3D fix. We're back to locked 6 satellites.
We should also mention that the checksum, which is an 8-digit hex ASCII number, is actually being verified on the Raspberry Pi side on the fly right now. So when it's writing it to the file, Kung is actually verifying that the data block matches that checksum. So we are actually checking the data when we're writing it.
And how big is the data block?
120 kbytes.
Thank you. Thank you.
Now, we have also run some tests that Bill was helping me on, is where does this thing run into trouble? So we kicked it up to a 10 kilobyte sample rate, and it was doing that fine. And when we turned it up to 12, when we go from 8 to 10, we lose one of the buffers. Right now we have 3 buffers that we're sort of ping-ponging or round-robining through. One's downloading, one's collecting, and one's being saved. When you go above 8, there's not enough RAM in the Pico to have 3 buffers, so we have to kick it back to 2 buffers, which means the process has to keep up. So when you're storing in one, you're writing the other one, this one has to come free before they flip over. And at 12 kbytes, we run into problems that it doesn't quite make the transfer over quick enough. And I believe we run out of RAM space on the Pico. Is that right, Bill? Is that where we run into trouble? Or is that
That's
it?
right. Yeah.
We run that because there's only 256
Okay.
of RAM for the buffer space on the Pico, and that's where we run out of room. So that really is right now the rate determining factor for the data stream going from the Pico to the Raspberry Pi, is we run out of buffer space. So we just wanted to know where we hit something as a benchmark, and that's where we hit. So that's the live demo. But
That's
we
the
are
first.
saving data in real time. I've had this running on my system at home now for 2 days straight. And one of the quality factors I'm looking at is the handshake signal that Bill sends back to me to say that the data was received. And that pulse width tells me how long it takes for him to turn it around. And when we were using the interrupt service routine to do this data collection, we were running into problems where it would miss after 125 microseconds. So we put it in just to a self spin loop in that one core. So it's doing nothing but looking for that bit, grabbing the data, and then sucking it out. And I ran it for 2 days looking for a 10 microsecond period. I didn't see it. I then changed it to 5. I ran it for a day. I did not see it. I changed it down to 2 microseconds. I still didn't see it. So then I really tightened the screws down. I put it down for a 1 microsecond. And after about about 2 minutes, I would actually hit it. It would be 1.25 microseconds. So we're turning it around in a little over under a microsecond normally, in terms of the handshake time of, okay, the flag went up, you went and grabbed all 16 byte, or 3 times 4, 12 bytes of data, and then handshake it off saying that it was done. And then the handshake finishes off. So that's in real time, that's where we're at. So we've got the system talking, and we have some overhead. It's not, 10 times or anything like that, but we're able to do it. And it runs consistently, and the checksums check, and we're not losing any data between the systems. So it's looking very, very good. End of demo. Back to you, Rachel.
Okay. Quick welcome to Tom Parrish. He's new. Did you have any update? Let me reshare the minutes on the magnetometer.
Actually, I've been spending all my time working on the RF deck production stuff and the board layout, so I hadn't had a chance to look at it this week, so I had no traction on that. I'm hoping to get to that next week or this coming week.
Totally fine, just checking in. Frequency standard issues.
We're using the Leo Bodnar on my system, and that is going to be the final architecture for the implementation.
I'm gonna mark that as completed then.
I'm finding no problems with that.
And I'm gonna leave this for an overall decision, I assume, to come in the future. For boardhouse stuff, I assume that's going to be a conversation between you and.
Yeah,
Okay.
we have to figure out, because I don't have any costs yet on the DAT panelization of the control deck, which the board's a little bit bigger, and there'll probably be just 2 per panel instead of 4. But I've got about maybe another 3 or 4 hours worth of work to finish up the control deck, because I know where I want it to be with the Leo Bodnar coming in. What you witnessed in the demonstration that Bill just gave is that when the GPS antenna disconnects, it goes into basically its own flywheel. It keeps running and sending out the 8 megahertz signal. So the 8 megahertz counter is still running. I do not believe that, I'm not sure. I haven't checked if the Leo Bodnar does that when it loses satellite lock. It may shut its output off, which case.
No, it stays free running.
It does stay free running. Okay. Which case, the Leo Bodnar then is going to be plugging into the 4th USB port, so we can actually query it. And I've got some software that I think we can do that, but if not, I'll be working with Leo directly and trying to get the information on satellite lock. The existing Grape 2, as it's going out, will still have the U blocks on it that generates the 1 PPS and the NEMA strings that Bill uses for the timestamps. But I have found a U-Blocks chip that is pin for pin compatible and $110 cheaper than the one we're using because it does not have the PLL on it. And I believe it has modes where it can be set to basically do a holdover on the output. But that still doesn't address the frequency output, and we still have to use Leo Bodnar. The Leo Bodnar doesn't provide the 1 PPS, so that's sort of the quandary I'm in. I knew I could probably go into the Leo Bodnar and pick the signal off and bring it out to a pin, but I'm not going to do that on 55 units. That would be an absolute nightmare.
Yeah.
So,
Okay. Any other hardware updates?
I'm going to start a conversation with Leo to see if I can get a discount if we buy 35 or 55 of these things. I don't know if he'll budge on that, but it's worth asking the question. Since over the last 3 years, I bought over 100 of them, either through this project or through another project. So he knows who I am. I haven't talked to him, but.
Okay. Nice. And once again, great board in all of its splendor.
Thank you. That was
All
a lot
right.
of work.
A lot of work, thanks.
On software. Is Kong on? I probably should check before I.
Yes, I am.
Nice.
Hello.
Any-
Oh yes. So John mentioned that the checksum is being verified on the Raspberry Pi. So yeah. So basically, the Pico, it will read the raw data. It will calculate its checksum, and then it will send that over to Raspberry Pi for data processing, along with the checksum. So when the Raspberry Pi receives that checksum, it receives that entire data block, it will calculate its own checksum. If the new checksum matches up with the one that was sent over, then that means the data integrity is good. So initially, we completely drop that data block if the checksum fails, but we have decided to change that and we'll write the data into the files regardless. But then if the checksum verifies, we will add a V at the end of the data block. If it fails, then we will add an X to the data block. So we let the user decide what they want to do if the checksum fails. Yep, that's it for me.
Thank you.
Yeah, we figured
Right.
we'd leave it up to the user to give them the data block because it may be just one byte is bad, or it might be obvious that they got a bunch of zeros or it dropped one of the bytes and everything else is good. So some data might be useful. We'll leave that decision up to the user. We are not going to make that for them. And it also makes the block writes to the files consistent, so you can instantly look at the file size in the directory and tell if anything's missing, because they will all be identical. So, and we're keeping the fields the same length, so the parsing is identical whether it's good or bad. So it's the same number of characters in the same positions. So we're cognizant of, somebody else writing code that's outside of our sphere of research, reading this stuff. I'm trying to make it as consistent and as easy as possible for them to do that.
Rachel, may I get a word in?
Is it about this?
Yes. I want to introduce Tom Parrish. He's a new member of this. He's working with me on the A Long Path project, but he is a career computer scientist, IT manager. Can we give him a 50-word or fewer overview of Grape 2 and to whom they will be distributed?
I guess that's pointed at me.
Yeah, okay.
No, Rachel, you do it. Grape 2 is basically a 3-channel version of Grape 1, where it's 3 low IF radios that are programmed ideally to be at 5, 10, and 15 megahertz. They all have a bandpass received bandwidth of 4 kilohertz. And that is being received by a 16-bit A to D being sampled at 8 kilohertz per channel. And that data is being saved real time on a Raspberry Pi into a file that has header information about what all was being received, what beacons are being active, who station it is, what the latitude, longitude, all basically the stuff that's self-contained in that file. So if you look at the file, you know where it came from, you know the data was collected, you know the time was collected, and it's got an hour's worth of data in it for the three 16-bit numbers, 8,000 times a second for the 3 radios. And that's essentially what, well, the Grape 2 also has a magnetometer interface on it, which we're going to be saving the magnetometer X, Y, and Z, and the internal temperature of the GPSDO, as well as the external temperature of the magnetometer, since it has a very sensitive temperature coefficient to it. And that file will be saved as well. So the Grape 2 will be saving 5 files in real time.
Okay, so John, Grape 2, 3 WWV frequencies, continuous recording, and to whom will they be distributed?
Right now, the raw data file of the 10.5 gig per day, we haven't decided what we're going to do with that.
Actually,
right
to whom will the receivers be distributed?
Oh, that is the Grape 2 distribution list that, oh, geez, what's his name?
Gary.
Gary, thank you. Gary Mill. How can I forget his name? Anyway, I'm not good with names. Gary has that list, and it's probably going to be echoing a little bit of what we did for the previous month's partial solar eclipse.
So it's 30 stations strategically located for the April eclipse.
Correct.
Okay, that's enough for the moment.
Okay,
good.
I may have extended my 30-second introduction. Sorry. Back to net. I'll shut up.
All right. Yeah, the 10-cent version is the Grape 2 is a supercharged grape. Yeah, it's a new variety.
It's the high octane version of the grape.
Yeah. Kazdan, did you have an update on the script?
I'm sorry, Rachel, I missed what you said.
Oh, I was gonna say, do you have an update on this or no?
On the progress for your frequency determination algorithm.
No,
someone has an open mic.
Yeah.
I don't accept that I'm revisiting the algorithm.
Now we are getting numbers out of it, and it's giving us exactly 500.0000 hertz at 1.00000 volts. So I'm presuming that's a placeholder still.
It's not supposed to be a placeholder still. All right, let's work on this one.
Either that, I was very impressed with your algorithm. It looked too good to be true. Back to net.
Okay. I'm going to, I assume, I don't know if Gary's here.
I'm here.
Ah.
You want to show off some website updates. I pushed you off for 2 weeks.
Yeah, this will only take a minute. I can do that if you let me, if I can share. Yep. So basically, there were some questions around the Grape 1 DRF pages. Is this shown on the screen okay?
Mm-hmm.
Okay. So I tried to put things in a logical order and add a little more information to the documentation page. People asked me to see the shopping list. So if somebody's interested in building one of these things, there it is. That's what we use to build, the New England group used to build their systems.
Wow.
Eventually, we'll have instructions for building an image for the Ubuntu new radio thing, but that's unavailable and that's under development. So that's a placeholder. Bill's document on how to do the external hard drive formatting. The startup guide that the New England Grape Group had written. There's a lot of useful information in there. And then follows on with Bill Engelke's document on data reporting and whatnot. So I think we've got a fairly complete page if somebody's looking for, maybe not enough to build their own Grape 1 DRF, but at least to get them their information kind of from top to bottom. Any comments on that?
This
Nice
looks
job.
great, Gary.
Okay.
Is the So is the only thing that's missing from them being able to do this from top to bottom the image?
I believe so, yes.
It'd be really nice if we could get that all put together before we go to Leesburg for the NASA Science Activation Conference on November 13th. Because it sounds like at the Science Activation Conference, one of the things they want are ways that educators and schools can get involved. It'd be really nice if we were able to just say, okay, yeah, if you want a project, here it is. And you just go to this one page and it looks like we're very close to that.
Excellent. I like it, Gary.
Good, thanks. But yeah, I mean, I don't know who is working on this or if anybody's working on this, how to build this image at the moment. So that's obviously I'll put it up there when we've got it, but
yeah, I think can you I guess Bill Engelkey is on. He would be he's the keeper of the GNU Radio DRF image.
Run, Bill.
Yeah, Gary, there's going to need to be a document in there that describes how to personalize the image that you get, because I don't believe that Bill Engelkey wants to be building personalized images for everybody.
yeah, I'd assume that eventually it'd be all in one document, but with that can be TBD.
Yeah, I mean, there's a lot of information in the current document about really the only thing you got to do is work the config file, and there's complete documentation on how to do that in that document. So
I was suggesting that be brought further forward. Your document is an excellent. It's a journey through everything involved with the Grape, and it starts at the beginning on how you work the central control panel. And that's very cool. But if you're trying to build one of these things, that particular part, which is in your document, maybe should be brought up closer to the beginning of his.
Yeah, that makes sense. I mean, we could put together something, or we could rearrange what we have there, or we could put together something specifically on that. And one thing that I do wonder about is we're going to give this to schools and expect them to build surface mount component device that requires a microscope and some specialized equipment and skills. That's a heavy lift, I think.
I agree.
Well, it is definitely a heavy lift, but one of the things that we've talked about is after we get the Grape 2 going to where it needs to be, we've talked to John about redesigning the Grape 1 to remove the surface mount parts. And I think there are various levels of schools out there, and some of them are more technical than others, and some of them might say, okay, yeah, one surface mount part, some Linux, they might say no problem. I imagine if we're going to a NASA Science Activation Conference in Leesburg, Virginia, I imagine that the educators that are making it out to such a conference in person might be among the ones that have access to those higher levels of technology, because it takes a certain amount of effort to get to an in-person NASA conference on a national level. So yeah. I think we just put it out there and we say this is, it is, we've definitely seen that volunteers can put this together. There's a lot of creative people out there. I think we put together what we have and we say, here's a way you can go forward.
Maybe the thing to do would be to panelize the Grape 1 and do a board run of 50 or 100 units and then sell them this, because I tell you right now, it is not possible to make that board with all through-hole parts because the mixer chip is not available in DIP, nor is the op amp.
Yeah.
So I can't do it. I mean,
that's
not doing this out of spite. I just can't do it.
Wait a minute. No, that chip is available in DIP.
Not anymore.
602? There are lots of them out there.
They don't make the 602 anymore. That's obsolete. The 612 is out there, but good luck finding the DIP.
There are lots of them up there. Go to
No, they're not. They're not.
I think it's a great idea to to basically make some kits or some pre-made boards.
Yeah.
I don't know who wants to manage that. This would be something. It seems like a perfect You know, of course, Case, you would have the first dibs on, you know, putting it together and doing that. But I think after that, this might be a nice tapper sort of product.
If they're
Well, let
willing.
me, let me wrap up the subject, but I'll take a look at Bill, at your document again. It's been a long time since I've opened that thing up. If the how to build an image stuff is mostly in there, maybe I'll pull it out and suggest how we might stick that onto the website, and I'll be in touch with you in the next week, and we'll try and get that done. So that's good.
We're basically talking about how to fill in the config file.
And right, yeah, that's got to be part of it, sure. So
Okay.
I'll say back to net then, Rachel.
Yeah, Gary, really fast. Did you take the Grape 1 out of the Grape 1, Grape 2 hosting form?
I thought I did, but I'll double check. Let me do that right now.
I'll preemptively take it off and count that as good if you believe
Yeah.
it's. Let's see. Grape 1 updates. Bill Engelkey, you had a update for the DRF. I will stop sharing.
Right, okay. You remember how the plots used to look, my first efforts on doing that. I have reworked that to do a couple of things. I am using, okay, I had my own specgram code in there. I found I was able to replace about 100 lines of code with a single command, and it seems to work fine. And I also came up with a custom color map so that I can display the waterfall in colors that are very similar to what you see when you look at your grape. So let me show you that. Okay, this. All right, this down here is the latest one. You can see the level of resolution it has is improved.
Mm-hmm.
Nice.
You see that?
Mm-hmm. Mm-hmm.
And I am no longer plotting the red dots. I don't know how you do that over the top of a spectrum, but I figured a way using the color coding to get the strongest signal to show up with a little bit of red there. So
yeah. I like it better this way than with the red dots. I thought the red dots were getting distracting.
Yeah, I agree that. So just looking through a few of them, these are coming out fairly decent, and I think I can improve the resolution on this even a little bit further with a little bit of additional code. So anyway, so this is, here you're looking at your eclipse day, and you can see several things. You can see the very nice eclipse signature. You can see where this person's device lost GPS lock a couple of times, and there's a lot you can see in these plots. And I think, I don't know what all of this is. Maybe that's some of the noise from wall warts getting included into the signal in some cases. I'm not sure, but anyway, that is, I wanted to get the students to put this into production this past weekend, but it was fall break and this and that. So we're going to try and shoot to have this working for next week. And I'll go back and replot everything on the system. So you'll have plots using the new color scheme and this new code. It's always possible to go back and replace everything with updated code each time I make an improvement to it. It's possible to replot all the old stuff if need be, because we have the original data for it. And you can see here's somebody's, this one went off part of the way through the day. And so you can see as the propagation on 10 megahertz drops off during the day, you can see the drop off in amplitude. But interestingly enough, on this one, you still see, even with poor propagation, you still see your eclipse signature in there.
Wow.
Yeah, I think this looks beautiful.
Yeah, this is much improved. So that first was like just a proof of concept, and this is more what I want to use in production.
Can you, Bill, can you send those to me or to the group, all of
Yeah.
them? Yeah, because
Yeah.
I'm going to be giving a talk at the Lackawanna Astronomical Society on Tuesday night. I'm giving a talk to Jay Schwartz's WB8SBI's Hazel Park Amateur Radio Club over Zoom on Wednesday. I'd like to start including, this is what we actually saw during the eclipse.
Yeah, I will take these and zip them.
Yeah.
And I will send, Rachel, do you want to copy this as well? You want to put it in the minutes or anything?
Yes.
Yeah, I could use a copy of them too for the documentation I'm putting together for that NASA conference.
Yeah.
Actually, putting a couple of those on the website is be a really good motivator.
Well, yes, I agree. I mean, you can probably start putting some of them on the Grape documentation website. And I sent an email out to a number of people this morning indicating that we should get a press release together of some of our early observations and results. And we should get that on the website soon, because these are really nice.
Yeah, and this also contains the you can see the feature. Let me see, there's a couple of places where you can see a feature where the little mystery thing that happens sometimes where the amplitude drops down for a while and then comes back, and we don't yet know what that is. I need to get with Tom McDermott and have him look at the GNU radio flow graph, because it's happening prior to when this data is digitized. I looked at this with HDF view, and everything looks, the data and all the software looks clean. It doesn't look like there's any place where you could lose an upper digit. So in after you've got the DRF, so it's happening before this stuff goes into DRF, whatever this is. Whatever it is, don't know what it is, but whatever it is, it's happening before the DRF step. So anyway, I'm not sure what it might be a little while before I have the time to get with McDermott on this, but I want him to look at the flow graph, because he knows so much about flow graphs that I think he can be a big help.
Do all your samples see the same dropout?
No, everyone is different, and some of them don't have it at all.
Okay.
It seems to be amplitude related, which tells me it's probably a floating point versus fixed point number. That's sort of what it feels like.
That I have the same impression, and that's why I want to get Tom McDermott to look at it, because I looked at this, I went over the thing, and I can't find it. It may perhaps it's in there somewhere, but I have not been able to find it. But you do see it kind of occurring in here where propagation gets stronger.
Mm-hmm.
And so it does make sense. I have the only place that I'm found out or suspect is in the Hilbert filter that takes the real output that comes out of the sound card chip and then converts it to complex for use in all the remaining functionality of the flow graph in the GNU radio part of the Grape software as it runs on the Pi. So yeah. So this one's kind of fuzzy. I'm not sure. Guess I gotta zoom in. It looks fine when you zoom into it. So,
but that data set would be the one I would give them to do the diagnosis, because that bouncing in and out is the glaring red thumb of the problem.
Mm-hmm.
Yeah.
That is the perfect data set for this. So
yeah. So anyway, that's all I had.
And all the noise went away. Yeah. Yeah, right.
Well, it's still there in the.
Yeah, but fainter, and of course that's what you expect from the lower graph.
That tells me it is a number issue.
Mm-hmm.
It sure does look like that.
Yeah, it's like a 16-bit integer is rolling over or something stupid like that.
That's my data, and I compared that with some other that I had from other days, And it is at the peak amplitude of the signal that happens.
Well, now here's a question, John. Is it possible that the audio output from the Grape is overloading the input of the sound chip?
It's entirely possible. The audio chip, I believe, is intended for a 1 volt RMS. So when you get above about 1.4 volts peak or 2.8 volts peak to peak, I don't know what the Sabrent card does.
It will not wrap.
Maybe
I would
this is
never
what it
design
does.
an audio A to D
I
that
would
way.
not expect it to wrap because that would cause other problems. It may clip it, but I don't expect that. But that could affect the spectrum if you're clipping it.
Now, on the other hand, you may have a format mismatch.
Yeah, it's going to
in
be
your
looks like some
analysis.
type of a number something. Is really what it looks like.
Say that again, John.
It looks like some type of a number, either wrapping over or incompatibility or something.
Yeah, it's the sort of thing that might happen if you're putting in unsigned and you get two's complement
Right.
Analysis.
Put a 10 dB attenuator in the antenna and see if it does it.
Well, we've already demonstrated that by the previous signal there. Once it stays below a certain amplitude, you don't have a problem. So it definitely looks amplitude related. Probably the thing to do would be to get a signal generator on the Sabrent at a frequency and just start cranking the amplitude up and see what the spectrograph does.
Yep.
That would be the easiest way to figure it out.
Man, I wish I had a signal generator.
Oh,
Okay.
you don't have one?
No.
Might have to fix that.
Yeah. All right, back to net.
URP Labs makes a real cheap one you can put together.
Yeah. Also, you supposedly if you have a working red pitaya, supposedly you're able to use it as a signal generator, supposedly.
Yes, absolutely you can.
And unfortunately, my red pitaya died, so I'd even have to buy a new one of those to use that. So, but anyway, back to net.
All right. I'm going to reshare the minutes. Graphs, and we can follow up probably on the amplitude drop off issues. I'm just going to move them up to Grape 1 DRF stuff because we'll probably want to follow up on that next week as well. Any other, I guess, updates on our old business? All right. Nathaniel, you wanted to show off some FL Digi data. We are running short on time.
Well, it's okay. I've got 2 plots, and I think it's just more to recognize these. And let me just make sure I have the.
And then
set.
Wanted to show off a plot. So if we can get that done in a bit. I didn't know how much time you wanted to talk about initial press releases.
We can talk about initial press releases more this afternoon at the 4 p.m. Meeting, perhaps. We'll get there with that, and we also have the email thread going. But anyway, I think Bill Blackwell, are you the one who made this?
Bill does.
Yes, Bill did.
What's that?
Bill does publish
Yes,
those every year.
they publish.
Great, yeah. So Christina sent this to me, and these are the observations of the FL Digi Grape observations from the New England Grape Group. And I think it just shows everything very nicely. So here you have dawn, here you have the eclipse signature superimposed from all these 10 megahertz stations. So I think this is a really, really nice plot showing the eclipse effects. And we also have the power plot as well, where you can also see the decrease in received signal level as a result of the eclipse. So I just want to point out.
Go ahead.
Yeah. No,
I
go ahead.
just wanted to credit Bob Benedict with as being the developer for this program. I just put it together into a script. go.
That's great. So yes, so thank you, Bob Benedict, and I know a few people had something to do with this script too, because I know I actually did some of the original coding on this, and so did Christina, and there's quite a few people.
Yeah.
That purple
So
plot is from British Columbia, which might explain why its level is so different than everybody else.
Yeah, they're seeing Hawaii a lot, we think.
Yeah, Dave ship switches back and forth all the time between Hawaii and Golden, and actually gets both of them. That's on a very good location on Victoria Island.
Does he use the same node number for both? What's that?
Pardon me, Nathaniel?
Does he use the same node number for Hawaii and British Columbia?
Well, no. He receives Hawaii. That's what I was saying.
Oh, he receives Hawaii. Okay, yes. Okay.
It's an overwater path all the way.
Yeah.
He's on Vancouver Island.
These are really good, and I think we'll have to try to get summary plots from the rest of the Grape 1 FL Digi stations as well. One other quick announcement. If you go to Rob Robinette's group, which not Whisper Demon. They're Rob Robinette and Gwen Griffiths from the Whisper Demon group. They've started putting out observations from their Whisper Demon experiment with the eclipse, and they have a new system called the Beacon Blaster, which can transmit 6 bands simultaneously, and these are GPS disciplined FST4W signals. So this is GPS disciplined transmitted signals on the amateur radio bands. And then they have their system is capable of decoding, of getting Doppler measurements from the FST4W spots. And they were able to show that here. So you can see, we can actually see the eclipse in the FST4W spots as well. So I think this is a tremendous development to have amateur radio transmitters being able to do Doppler measurements as well. So I wanted to give them some recognition, and I think it'd be very nice to be able to look at this data in concert with the Grape data as well. So you can go to Whisper Demon. What is the website?
You can
Technical. You can go to whisperdemon.org and click on technical, and you'll get that. Back to you, Rachel.
Actually, back to Dave, who had some ground observations at WWV. He wanted to show off. Unless he had to run.
No, I'm here. Let me make sure I can share my screen. I'm running into some problems, Rachel. I'm not going to be able to do it.
That is okay.
Hold on. I'm just trying to get going here. Sorry about that. Let me see if I'm sharing or not.
Yes, you are.
Okay, this is the famous FL Digi output here in Fort Collins.
I'm so jealous.
And not a hint of anything unusual. This is what you'd expect. We've got a nice strong signal and no wavering of the frequency. However, this is the plot that I get with the GNU radio system, and every morning I'm getting this strange Rorschach drawing showing up on here. I got a good signal down dead center. I should all the way using a vertical antenna. I do have those 1 kilohertz interference I think you were just talking about. But why am I getting that Rorschach image on there. I don't understand why.
That's multipath.
Well, it's interesting here in Fort Collins. I'm only 13 kilometers from WWV, but I get WWVH, and usually with a horizontal antenna. So I put up a vertical antenna to try to enhance my reception of WWV's vertical signal, or at least the ground wave should be at this point. And I'm still getting some kind of a pattern, and it's showing up right at sunrise, just like we get with everybody else's FL Digi measurements. And I was just curious, it doesn't always happen, but it's there almost every day. And I'm just curious what would be causing that. Am I getting some kind of NVIS from, the D layer forming right above me? I don't know.
It almost looks AM modulated. But usually for these Doppler shifts, we usually see either a positive swing or a negative swing, but not
Right.
this mirror imaging.
Right. And so I don't know what that mirror imaging is. And
Have you sent this to Steve Serwin?
no, I haven't sent it to anybody. I just brought it up with you guys. So
Yeah. Can you send it to Steve Serwin and ask for his thoughts?
yeah, I'd be glad to.
Yeah, Dave, I'm wondering if a HF loop might help you resolve that. Using a loop antenna, you could null it in the WWVH direction and see if that makes a difference. That would be sensitive to stuff coming from above, but not from the west.
It's
depending
amazing.
on orientation.
With a horizontal antenna, I sometimes get WWVH better than I get WWV. Here, just it's
right.
It's really interesting how that happens. So you'd think
what was the orientation for your horizontal?
It was oriented towards Hawaii. So it's
yeah, you might.
Yeah.
So broadside to Hawaii.
I can't change that.
North south. Okay.
Yeah.
Yeah, it'd be interesting. Of course, the thing is that even if you orient it east-west so that Hawaii supposedly nulls, you're getting a sky wave, which is going to come in anyway.
Right. Well, I'll pass it on to Steve and see what his impressions are.
But yeah, if you got one of the HF loops and oriented it, you could move that around and see if
that's a good idea.
Different.
The other thing I wanted to bring up and get some help from a few people, maybe Bill Engelke could help with this, but I have a very strong interest from Wellington High School, which is right next to WWB, to bring in the two receivers, the FL Digi and then also the GNU radio. And it would be a great place to put it. My big problem is going to be getting the equipment onto a school district's computer network, and the reluctance to have anything that is not commercially made and traceable, and for the school district to have a really good knowledge about what the equipment is that they're putting onto their computer network. So I've got a sell job that is going to be difficult to try to convince them that this is a good thing and that they should allow these Raspberry Pis to sit on their computer network. And so if anybody's got some good words of advice on how to sell that and to convince them that we're not going to introduce viruses and things like that into a school district. So
does it help at all that this is a NASA funded project?
I think all of that will help, but I'm just kind of curious if anybody else has tried to stumble, dealing with IT departments and getting equipment put on there that's very formal or foreign, excuse me, to a school district, and they're rightly very concerned about it.
Yeah. No, it's a problem. It is a regular problem that is increasingly problematic, and I have to deal with that here at Scranton as well.
Right.
And it is very, very difficult.
But that Raspberry Pi is an educational project. I wonder if their site might have some clue on that.
Well, anybody can write a program and put it on a Pi that could be malicious. I mean, that's what they're concerned about, is something.
No, I understand that. I'm saying that the Raspberry Pi was designed to be used in the schools, so they may have some insight into those concerns.
Yeah. Well, we'll see. any experience people have had would be great.
There's another thing that you can do, not necessarily for free, but there are, you might want to stay off of the school district's network entirely and get a Wi-Fi thing from T-Mobile or one of these companies where it provides a Wi-Fi, it picks up a cellular signal and provides a local Wi-Fi hotspot, and you can connect equipment to it over the air without using the local network at all.
That can get expensive over the telephone.
Sure it can, but if the school district wants this, they may be willing to pay for it.
Well, that's always the school district wanting it and being able to pay for it. As a public school teacher for 30 years, that's the juggling game. It's
right.
Money. I don't have any money to put into a private service like that, but it would be, I understand what you're saying. When you do the file transfers, Bill, that only happens at the end of the day, and that's 35 megabytes, and then that's the only time that it's ever needed. Is that right?
Right. The way it's designed right now, that is correct.
So during for a majority of the day, you don't have to communicate with the server.
Correct.
Yeah.
As a point of reference, right now the 5G home internet is $30 a month. Of course, if it's schools buying it, that's going to be probably more expensive. But
just Dave, have you spoken to the curriculum director at these schools?
Oh, I know all the people that we need to know.
Well, no, but they might be able. They would be the best person to know if there's a grant that they might be able to apply for to help support things on their end. Because that's
yeah. I'm worried about
I
just
think one of
with the school district, seeing if we can get on the, they've got a very good network. There's no reason that it shouldn't be on there. It's just, convincing folks.
One of the things, I think a battle that should be fought, and again, it's one I'm fighting here, is, the way we're seeing these networks go is they're starting to run the security in such a way that if it's not Microsoft PowerPoint and Word, web browser and email, it doesn't fly. And I think you should really try to get, from an educational standpoint, I'm really against that. I think, that's basically saying that the only thing you use computers for are Word, PowerPoint, email, and there's no chance the students are losing out on tremendous learning opportunities that are absolutely critical for today's society if they don't have a way of doing things like putting Raspberry Pis on networks and doing something beyond just Word, PowerPoint, and email. And just from a philosophical and educational standpoint, these school districts should be investing in a system in a network architecture that allows them to host not only this project, but other similar sorts of projects.
No.
That is a fair, philosophical concern, but I feel like that's going to be very hard to override the safety concern.
Yeah, you got lawyers and politicians making the decisions. They don't give a rip about your educational goals.
Dave,
no, I realize that. I do, believe me, I do understand that. Again, I fight the same battles here. But if you are trying to go at a multi-pronged approach, if you get the curriculum people and the teachers on board, you get them to help amplify your cause.
Dave, would it be possible to set up a special guest network for your system?
They do have a part of their network that's open to the public, but it's horrible. I mean, as far as getting IP addresses and everything, it's just I've used it. It just isn't up to snuff, and they're not worried about the public access of the network. They're worried about the school access.
Another thing you might consider, Dave, is tell them that you only want a 1 hour window at midnight or something, between midnight and 1, that this port would be open. They may consider that to be a lot less of a risk.
Well, that's the other issue, is it would be good to probably know all the ports that we're using, things like that. Any of those little details would be good as far as, the file transfers. What's the file transfer we're using, by the way?
I have to go in a minute, but there is one more thing that might help. We're here at Scranton. I'm having them install a RBN WhisperNet PSK Reporter aggregation software package that Bill Engelkey has, his team at Alabama has developed. And I went over to my IT department. I said, we want this installed on our server. And the first thing they asked for is, well, can you give us more information about how this software works? And, you know, what I did, Bill had written up a requirements specifications document for the software. So it was actually documented. And I sent that over to them, and their IT team was like, oh, this is very helpful. Thank you. And that really helped smooth out the process. So maybe one of the things we need to do is we need to write, as a team, we need to write a similar sorts of documentation for the Grape, so that when these things arise, you know, they say, well, is it documented and is it tested? And we actually have a procedure. We go like, yeah, it is. And maybe this is really, maybe this is the way forward, because that's what they're asking for. If we can give it to them, then there's less of a problem.
I think anything proactive like that would be great. So yes.
Yeah. And then it's less of a fight.
Documentation and communication.
Yeah. And I think that's what they're asking for. So if we have it all, you know, yeah. Anyway, I need to go. Maybe we should put that on for a future discussion point and get someone figure that out. Thanks, you, guys. Everyone. I will see people at 4.
7 3s.
73.
73.
That's everything.
Director.
Rachel, I'll let you stop the recording and stuff when you're all done, okay?
Oh, I mean, I am done. I just was gonna say something to Dave.
Okay, great. I'll stop it.